What's up everyone, hope you guys are doing well. In this video we're going to be talking about graphs of trigonometric functions. Now this is part 4 of the Add Math Trigonometry video. I've already uploaded the first 3 parts and I'm uploading this part after quite a while, so apologies about that. So there are 3 basic graphs in our syllabus, and they are sin x, cos x and tan x, and that's exactly what we are going to learn in this video. We're going to learn how to sketch these graphs and we're going to learn various things about them also. So let's start with the very first one, which is y equals to sin x. Now you can see here that I've given a range. Now this means that I'm only interested in the part of the curve that starts from 0 and goes till 360. Okay, so a couple of things that you must remember about sin x is that whenever you're taking values, meaning that the values of x, so you start from 0 and you go all the way to 360, but you take a step of 90 degrees. That means you take a break of 90 degrees. So that means once you plug in 0, the next value that you're going to plug in is 90. The next value that you're going to plug in is 180. Then right after that 270 and then 360. So remember, these are all the x values and these are all the corresponding values that you are going to get. So I'm just going to quickly grab my calculator. So if you work out sine 0, you'll notice sine 0 is 0. Sine 90 is 1. Sine 180 is also 0. Sine 270 is -1 and sine 360 is 0. Now there is a way in your calculator, there's a mode called the table mode through which you can see what the corresponding values are without actually having to plug them in again and again. I think I'll make a video on it and post it whenever I get the time. Okay, so here we go. So remember, what we're making is a sketch. We're not plotting it, we're just making a sketch. So here's my x-axis. This is where all the angles are going to be. Here's the y-axis, and this is 1. Let's say this is -1, and this of course is 0. So at 90, the corresponding y value is 1, so we have 1 point. At 180, it's 0, so we have the second point. At 270, the corresponding y value is -1, so we have the third point. And then finally at 360, it comes back to 0. So I'm going to highlight the 4 points. So here's 1, 2, 3, 4, 5 actually, sorry. 5 points. Now we need to make a smooth curve and join these 5 points. So there you go. So far so good. Don't mess this up, please. Yeah. Okay, so a couple of things, like I said, that you must remember is that the maximum value is equal to 1. Okay, the graph of sine x, okay, it doesn't go beyond 1. The minimum value is equal to 0. And there's something else. Now that is called the natural period. Now that basically means the number of degrees after which one cycle ends. Now what do I mean by that? That means, so if you were to plot this graph further, you would notice that you will get the exact same shape over and over again. So that means one cycle completes after every 360 degrees. So we're going to conclude that the natural period of sine x is basically equal to what? Is basically equal to 360 degrees. Now remember that by definition, natural period is basically the number of degrees it takes for a cycle to repeat itself. So the natural period of sine x is 360 degrees. Okay, so I'm just going to erase this part, it looks untidy. Alright, so that was sine x. Now let's see what happens in the case of cos x. Again, we're going to start from 0 and we're going to plug in values after every 90 degrees. So we start at 0 and then 90 and then 180 and then 270 and then 360. So you'll notice that cos 0 is 1, cos 90 is 0, cos 180 is -1, cos 270 is 0, and cos 360 is back at 1. So let's quickly make a sketch of this and see what this looks like. Alright, so here we have 90 and 180, 270, 360. So here's 1, here's 0, here's -1. So at 0, cos is equals to 1. At 90, cos x equals to 0. At 180 it's equal to -1. At 270 it's back at 0, and at 360 it is back at 1. So let's join these 5 points with the help of a smooth curve and see what do we get. So there you go. And yeah. So here also you can see that the maximum value is 1 and the minimum value is -1, and it is equal to everything in between. And here also the natural period is equal to what? Is equal to 360 degrees. Why? If you were to draw this again, if you were to extend this beyond 360 degrees, you'll notice that you get the same cycle over and over again, which is why the natural period is 360 degrees. Okay, now we look at something called tan x. So let's see. So y equals to tan x. And again, we're going to start from 0. But in this case, we're not going to take the break of 90 degrees. That means we're not going to plug in values after every 90 degrees. Instead, we'll plug in values after every 45 degrees. So here's what happens. 0, 45, 90, 135, 180, 225, 270, 315, and 360 degrees. So tan 0, sorry, let me just write it here so I don't mess it up. Tan 0 is 0. Tan 45, you'll notice, is equal to 1. Tan 90, now here's something really interesting. Tan 90 will give you infinity. Okay, and we'll come to this. We'll discuss how we're going to plot this in the graph. And then tan 135 is going to give you -1. Tan 180 will give you 0 again. Tan 225 will give you 1, 270 again infinity, and then -1, and then 360, 0. Let me just double check. Tan 225 is in fact equal to 1. Yeah. Okay. So here we are. Here's the y-axis. Now I'm going to draw this slightly larger than the other previous one. And here's the x-axis. Now the graph of tan is really interesting. I'll show you why. So here's 90, here's 180, here is 270, and here's 360. Now in between, of course, we'll have 45, and halfway between 90 and 180 we'll have 135, and then we'll have 225, and then 315. Okay, now there's something in the graphs of tan which we call asymptote. Now what are asymptote? I know it sounds funny. It is a funny word, but asymptotes are basically lines that a curve approaches, infinitely dotted lines, by the way. It approaches it, but it never cuts or touches it. Okay, it just approaches the asymptote. It just approaches this infinite line, but it will never touch or cut it for that matter. Okay, and here we'll have two asymptotes to be precise, one at 90 and the other at 270. Okay, so what's really interesting to see here is that when you plug in tan 0, you get 0, okay, no doubt about that. But when you plug in 45, you get 1, again, no doubt about that. But when you plug in 90, what you get is something called math error, which basically means infinity. But if you plug in tan of 89.99999, you'll notice that you get some value, okay? It's a fairly large value, 572 million, something like that, okay? So what this really means is that this graph is approaching 90 degrees, but it is never equal to 90 degrees. So that means the second I plug in tan 90, I get a math error. See, math error. So what that basically means is, like I said, the graph will approach this dotted line, but it will never touch or even cut it for that matter. So in that case, our graph will look like this. You can see it's approaching this line. I think to make it fairly neater, I should bring this one down. Yeah. So you can see it is going to approach this line, but it's never going to touch it or even cut it for that matter. If it's not going to touch it, then of course it's not going to cut it. Okay, now what happens after 90 degrees? So you can see, you know by now that tan 90 is equals to math error. But if you plug in tan of 91, you get a value and it's a negative value. And if you plug in tan of 90.000001, Again, you get a value, and it's a fairly large value, but it's negative. So that means right after 90 degrees, what happens is that our graph goes from positive infinity all the way to negative infinity. And at 135, you can see it's equal to minus 1. Oops, sorry. 135, it's equal to minus 1. And at 180 is equal to 0. So that means it's going to come all the way from negative infinity. It's going to be minus 1 at 135. And then it's going to be 0 at 180 degrees. So this right here is one complete cycle. Why? Because at 225, we get the exact same pattern. At 225, it's equal to 1. At 270, it's equal to infinity again. So this is what it's going to look like. Go all the way up, come back up from all the way down, and then back to 0. So we can't determine the maximum or the minimum value of tan, but what we can determine is something called the natural period, like we just saw earlier. So here you can see that one cycle ends at 180 degrees. Why? You can see from 0 to 180, if you just focus on the shape that's from 0 to 180, you'll notice it's very similar. In fact, it's exactly the same as you would get from 180 to 360. Okay, so I'm making these boxes so that it's easy for you to identify. Which is why we say that the natural period of tan x is basically equal to what? Sorry. Is equal to 180 degrees. Why? Because this completes its cycle after every 180 degrees. So I'm going to move these boxes because they're just making my graph look weird. Okay, so this was just an introductory video of graphs of trigonometric functions. And there is something, however, I'd like to mention here, and that is the amplitude. Okay, we're just going to look at the formula and we're going to look at it in more detail in the next video, inshallah. So amplitude, remember, by formula is simply equal to the maximum value minus the minimum value divided by 2. So that's the formula for calculating the amplitude. Now there are some other formulas also, and there is some tweaking that we're going to do to our graphs, and we're going to see how we can plot them, but not in this video. That'll be for the next one. So I hope you guys liked this video. I had been getting a lot of requests from you guys to make a part 4, so here I am. And that's all for this video. I'll see you guys in the next one. Until then, take care. Bye bye.